All right, now today and tomorrow we will focus on the concept of inverse functions. First, I want you to know that actually are two things going on here. If you look at the topic here, I'm going to say there's one thing called the inverse, and there's another thing called the functions. Now, before we talk about the inverse part of the term, let's talk about functions. Do you still remember back in Algebra 1? How can you tell if something is or is not a function? So how do we tell if something is a function or not? It's what? If the x value repeats, I mean, that would, if the x value repeats, when what happens? Because I think you're getting closer to the idea, but there's a very easy way. Do you remember back in Algebra 1? There's a very easy way to tell if something is a function or not. On a graph, yeah. With a pencil, what do we call it? The vertical line test. Yeah, so we can say, oh yeah, let me go ahead and show you two graphs. And one is a function, one is not a function. Can you tell which one is not a function? We'll say, hey, if you have these two kinds of parabola, since we were just talking about parabola, the one on the left is or is not a function. It's not a function because if you draw a vertical line, it will touch the graph twice. And we say that's not a function because there are two outputs for the single input. But on the right, we call it a function because every single x value has a y value, had only one y value, so which is a function. So if you don't understand what a function really means, we tend to we can use it as an analogy. We can use an analogy to explain it. It's like a machine, okay? Like a pasta machine, okay? What do you expect a pasta machine to do? To make pasta, right? You would not expect a pasta machine to make soda and pasta. If that's the case, we say, wait, hold on, is that a pasta machine? Okay, so a function is like a machine that it only does one job. And if it does one job, that means we say, oh yeah, it passes the vertical line test. But if it fails the vertical line test, then we say, oh, that is not a function. Okay, so that's the function part of the topic. And now we will talk about what inverse is. Well, what's an inverse? Okay, it says that an inverse relation interchanges the input and output values of the original relation. That's kind of fancy. So let's go ahead and use an example. Now, I want to show you that you already knew a pair of inverse functions. All right, do you know about x squared and square root in the past, back in Algebra 1 or geometry? Do you know x squared and square root? What can you tell about the relationship between these two functions? What happens when you put them together? Square root and square. If you put them together, what's going to happen? They will cancel each other out, right? It's just like, oh yeah, I have a simple question for you. The simple question is this: x squared is equal to 9. And what would you do to get rid of the square? You would say, I would take the square root to get rid of the square, right? So that's actually the very simple idea of inverse functions, is that they cancel each other out. But what do we actually write in math to show that they cancel each other out? This is the part. Now, if you have a highlighter, I would strongly recommend you to highlight this part. This is this is the official definition of what inverse functions are. All right, they, like in simple words, we'll say they cancel each other out. But how do we show people that they cancel each other out? We say, oh yeah, imagine there are two functions, which we'll show in a moment. If you put one into the other function, then all you would have left is just x. That is how you show an inverse function. Okay, so now this is the part you really want to put a star next to it, because you will have functions that you have to prove, and the way to prove it is by doing this test, by saying f of g of x and g of f of x. Okay, so we have two functions right here, f and g. We call it f and g, or f function and a g function. F function is x squared, and the g function is the square root. So we say, hey, could you go ahead and put the g function inside the f? Now, for some of you, it might be a long time since the last time you did composition of functions, so you may want to refresh your memory. Oops. When we do f of g of x, that means f is on the outside, and g of x is in the inside. This is the g of x. We put the g of x into f of x. And you look at this, you say, oh, yeah, you have a square root x inside, and then you have a square on the outside. They cancel each other out, so you have just x remaining. And then you would do the reverse. You would say, what about g of f of x? And we say g of x is this, and you would insert f of x, which is x squared, in to the g of x. Now, if anything right here looks a bit more a bit complicated, and you want some further explanation, I can give you one. Now, let me give you an example. Okay, you have f of x being x squared, right? Now, could you tell me what you would do when I show you this annotation? What is f of 5? What do you do? What's that? 5 squared, right? So you would put the 5 into the place of x, right? Okay, that's what it means. You're telling the world that, hey, we have a little change right here. And the change is that our new x value, it's 5. So therefore, you would know that you put the 5 into the place of x. So now we say, hey, could you go ahead and put the g of x as our new x value? And we say, oh, sure, what's g of x? G of x is simply square root of x. So if I use color coding to show you what's going on, all right, so they are analogous to each other. So if you know how to do f of 5 in this situation, then you actually know how to do f of g of x. It's just that your notation may not be very fluent, and you might need a little bit more assistance to understand the notations, but actually it's the same thing. So in order to tell if something is a function or not, this is what we do. We do f of g of x, and we do g of f of x, meaning that we put those two functions into one another to see if it yields x as our final answer. If it does, then we say, yes, they are inverse of each other. Okay, that's a key part of this test.